In this video, we're going to be looking at Chapter 11, Describing Data for Math 142. This video will cover the idea of a 5-number summary and box plots. So we'll start with some definitions. The 5-number summary is exactly what its name says. It's 5 numbers that we use to summarize a bunch of data. And the things that we put in this 5-number summary, it's important to note they have a certain order that they need to go in, and they correspond to some of the information that we've looked at previously. So the 5-number summary is as follows. You have the minimum value comes first, and then next is the value for quartile 1. And we haven't talked about that yet. We'll talk about that in a moment. Next is the median, and we have used that term before, and we know how to find the median, is that sort of center value. Sometimes you'll also see that listed as quartile 2, so I'll list that there as well. Next, you'll have the value that lands at what we call quartile 3. And then finally, you have your maximum value. So the way that these work is they sort of match up with our box plot. So a box plot is a way to display data that will look something like this. You're going to have a nice long line going through here, and then we'll have a box that goes across here, and there'll be a line somewhere through that box. It's not always right in the center. It's not, everything is, I just sort of made a random kind of overall box plot. Box plots can have different types of shapes happening, but this is how we can represent our data. And this is where the idea of those Qs, the Q1, Q2, Q3, and that sort of thing come into play. The values that go with each of basically kind of the vertical lines that you see. Each vertical line here is one of the values in our 5-number summary. So all the way over on the left is where we would write our minimum value. And then I'm going to jump to the center here. This center line here, well, the center of the 5 lines. I don't mean to say that it has to be actually centered in the box or anything, but that middle of the 5 lines there is our median. Again, that can also be Q2. So over then all the way on the very right is our maximum value. So the 2 that we've left off are those Q1 and Q3 values. So the way that we find those, and we're going to use a lot of technology to help us find these, and we're going to be looking at box plots and interpreting things a little bit. But if you had to find those values, basically what you would do is find the median of, let me change over here. If we wanted the Q1 value, we would look at this the data just between the minimum and the median and find the median of that set of numbers. And then you would do the same thing over here. Between the median and the maximum number, if you were to line up those data numbers and find the one right in the middle, the median, that's what our Q3 would be. What the box plot does is it divides our data into 25% or 1/4 chunks. So 25% of the data will be here. 25% of the data will be here of all those values. 25% of the values will fall there, and 25% of the values will fall there. So it's a way to kind of organize our data in those quarters or 25% chunks. So one other piece of information that I want you to be aware of, or a vocabulary term, is when we look at this area here between Q1 and Q3, this sometimes is referred to as the IQR. You might see that in homework. You might be asked to know what that means. So I want to make sure you have that, that information there and that vocabulary. So IQR is the interquartile, make sure I spelled that right. Yes, interquartile range. So the range of the values from way back when we were looking at our first definitions in Chapter 11, the range is the difference between the min and the max. The interquartile range is the difference from between Q3 and Q1. So if you see that terminology or that abbreviation, now you'll recognize what that is. So let's play around with this idea of 5-number summary and box plots. So we're going to slide down here to example 8. So the following list, it says, provides the tuition rates in dollars per credit hour at a sample of 15 colleges and universities. So we want to find the 5-number summary for the data set. Now, the good news is we are going to do this. I'm going to show this using the technology and remind you how to do that. If you need to go back and do it by hand, again, you know all the terminology or all the police things you would need to find. You can find the minimum just by looking at the list. You find the maximum just by looking at the list. The median, line them up, find that central value, and then take your lower half of your data, find the median there. That would be your Q1. Take the upper half of your data between the median and the max, find the median of that set of numbers, and that's your Q3. The good news for us is that our calculator can help us with this. And if you were to go back and use the same steps that we did to find the standard deviation, what you'll notice now is if you go back and look at that, the list of numbers that you're given and values that you're given will be given to you for all of the values you need for the 5-number summary. So if you go back, grab your calculator, hit the stat button, go over to edit, and then enter this set of data into your L1. Then we use stat calc 1 var stats. Again, if you want to go back, the instructions were in the previous video. You can see exactly what buttons you need to push on your calculator, and then hit calculate. And when we were finding standard deviation, we were really only looking, sometimes we were grabbing the mean as well, but we're looking just for those standard deviation values. But if you look at that list carefully and you scroll up and down using your arrow keys on your calculator, you can see that the median is there, the Q1, the Q3, everything that you need. So take a moment to grab your calculator, maybe hit pause on the video, enter all those numbers in your L1 and calculate. And then once you have the window pulled up with all of the values in it, you should be able to list the values in order. Again, we start with the minimum, Q1, median, Q3, and then maximum. So if you need to take a pause, go ahead and do that. You should have gotten for the 5-number summary then, 87 was our min, 175 is Q1, the median was 218, the Q3 value is 416, oops, there we go, and the maximum value is 1300. So that's what we would consider our 5-number summary, and if you were presented with that, it would be understood that the order matters. Each of those represents a specific data value. So let's draw kind of a rough sketch of what the box plot of this data set might look like. So I'm going to start with just a nice long line here in the center. And then I can kind of see, if I take a look at my min and my max, we have 87 over here and 1300 over here. So it's quite a span of values there. So next we would need to put the boxes in. Now I'm not going to draw this exactly perfectly to scale, but I'm going to try and get close-ish, right? So 1300 is way the heck over there on the right, 87 over here on the left. I'm going to actually take a look here at my my median, 218. So 218 maybe is, I don't know, over here. It's a lot closer to 87 than it is to 1300. I probably could have even put it further to the left, but I'm going to leave it right here for now. Again, this is not perfectly drawn to scale. We're just kind of getting an idea in our heads of what this should look like. So from there, we're going to move to the left a little bit where we think 175 might land. And then 416 to the other side, maybe something like that. So this might be, again, this is just a rough sketch, but this is generally what our our box plot would look like for the data set. And we just use these values up here to create that. And many times we're going to be looking at box plots, not necessarily creating them, but it is important that if you're asked to create a box plot, you know, okay, I need my 5-number summary, and then you want to try to organize the values so that you have it fairly representative of how big and small the boxes are and how far away things should be. In this case, 1300 is way out there to the right, so I needed to shift my box more toward the left. So the next question asks you to find the percentile of the data set. And I realize I skipped over this, so we'll go back up and talk about it. Here's percentile. The percentile is a definition up there. Again, you might pause real quick and just jot that down. A percentile is the value below which a certain percent of the data values fall. So it's kind of the top value, everything below it we would count up as a certain percent. And since we know that each, in a box plot, as we talked about earlier, each of these represents 25% of the data, then we can use that knowledge to help us figure out these percentiles. So if we're asked to find the 25th percentile, again, that means we want to find the value below which 25% of the data values fall. So from here, this way, that's 25% of the data values are below 175. Percentile can sometimes be a little bit of a tricky concept for some people, so keep that definition handy and keep working with it if it's a little bit confusing at first. So the 25th percentile is 175. Then for D, it says find the 50th percentile for the data set. So you can almost think about it, could have done this for the last one too. We start here and say, okay, there's 25% of the data, that gets me to here, and then 25% more of the data gets me here. So that means 25 and 25. There's 50% of the data are below 218. So that gives me the value of 218 is the 50th percentile for the data set. Sometimes you may recall or you may have seen before when you were younger, maybe taking standardized tests in school. A lot of times they gave you your scores in percentiles. So if they told you you scored in the 80th percentile, it doesn't necessarily mean you got an 80% on the test. It means you scored better than 80% of the other students who took that test. So it's a little bit of a different way of measuring in comparison to others as opposed to just a raw score on a test. So you may have seen that idea before. All right, let's continue here to number 9. So we have 30, so we're going to look again at a 5-number summary, but this time our data is just being given to us in a little bit of a different way. We're going to use a frequency distribution table, and we've seen one of these before if you've watched all the videos up to this point. So it says 30 randomly selected students were asked the number of pairs of sneakers they owned, and the results are listed here. So when we go to do our 5-number summary, again, I'm going to have you use your calculators for this. Go into that stat edit menu again, and we have to think about what we need to type into our list. So remember, when you have a frequency table, these are the numbers that you're going to type in to your L1. This is how many times you're going to type each number. Now, there are a lot of numbers in here, 30 numbers. There are going to be 30 numbers in your L1. So go slowly, be careful, make sure you hit them all correctly. But we would start with the number 1, and we would have that 3 times. And then we go to the number 2. So 6 students gave the number 2 as their answer, 2 pairs of sneakers. So 1, 2, 3, 4, 5, 6. Next, we go to 3 pairs of sneakers. That was 8 students. So we have 8 threes. Let me make sure I get that right. 1, 2, 3, 4, 5, 6, 7, 8. Yep, we got them. And then next, 4 pairs of sneakers. We need that 10 times. There's 10 fours. And then 5 pairs of sneakers. That was 3 people answered that. So 5, 5, and 5. Now, you could probably type that directly into your calculator. You don't necessarily have to list it out, but I do want to make sure that you know what that list is. So this is what you should have typed into your calculator in your L1. So take a second to try that out and then come back here for the answer. The 5-number summary for this data set is 1 for the minimum, 2 for Q1, 3 for the median, 4 for Q3, and 5 for the max. That's kind of a nice, satisfying 5-number summary. And then finally, we're going to draw a box plot for this data set. So this one is nice and even here. So when we go ahead and draw this, we're right in the center there. It looks something like this. Again, I'm not drawing this with a ruler and not making it exactly perfect, but the idea is still here. So here's our minimum is 1. Q1 is 2, median is 3, Q3 is 4, and the max is 5. So we'll take a look at some box plots that have already been created for us and do a little bit of problem solving and analyzing of an analysis of these box plots with the questions being asked. For number 10, we have kind of a double box plot. So we have the same scale down here at the bottom of salary, but we're looking at 2 different jobs. So we have CPAs, that's a certified public accountant, and actuaries. An actuary is a it's a job usually in if you go to college to become an actuary, you're in the math department. It's actuarial sciences. And actuaries help to do some sort of different things. But one thing that that people think of them mostly for is sort of helping set numbers for insurance companies and kind of looking at data and percentages and probabilities of certain people with their ages and health conditions and different things, and kind of setting those the scales that way. And actuaries tend to be paid fairly well. So it's a job that it's a difficult degree to get for some folks, but it can have a good payout at the end. So anyway, moving back to the question, A asks, what's the 5-number summary for CPAs? So we're going to use each of these. Again, pretty much every vertical line that you see gives us the values for our 5-number summary. So our 5-number summary here is going to be 30, 40, we're going to call that 75 there, 90, and 100. Then we can do the same thing, 5-number summaries for actuaries. So again, we start over here. There's my min, Q1, median, Q3, and maximum. So let me get rid of those little lines there. So we'd start with 40. Next is 75, 90, 95, and 105. So the question now is to sort of analyze this and look at it. Kendra makes the median salary for an actuary. So I'm going to come up here and mark that. So an actuary median salary is going to be this line right here. So this is Kendra. And Kelsey makes the first quartile salary for a CPA. So we'll go to our CPA, and we have that right there. This is Kelsey. Right there. So who makes more money is the first question, and then how much more? So we can take a look down here directly below each of these. We can see that clearly Kendra makes more. And we can go ahead and we'll list it, kind of put both answers in one sentence here. She makes more, and then the question is how much more? So Kelsey's at 40, Kendra's at 90. So if we find the difference there, 90 minus 40, we get $50,000. So Kendra makes $50,000 more than Kelsey. So now look at number 11. We're going to refer back up to our same box plot here. And it says, what percentage of actuaries make more than the median salary of a CPA? All right, so the median salary of a CPA is what I'm going to mark off first. It's right here. And if we kind of drop this down and then take a look at our actuary scale, remember that each chunk of the box plot, as soon as you go from one vertical line to the next, that's 25% of our data. So from here to here is 25% of the actuaries. Here to here is another 25%. Here to here is another 25%. So if the median salary of a CPA is $75,000, then we can see that there are 3 quartiles above that for an actuary. So we would say that 75%, the percentage of actuaries, so 75% of actuaries, whoops, spelled that crazy, hold on, make more than And I'm just going to put the actual value here was $75,000. I don't know how current this data is or where this data came from, but so that may or may not be truthful for the real world at the moment, but for this particular box plot, that is the case. 75% of actuaries make more than $75,000, which was the median salary for a CPA. So finally, we have one last box plot to analyze here. So a survey was conducted of 130 purchasers of new BMW Series 3 Series cars, 130 purchasers of new BMW 5 Series cars, and 130 purchasers of new BMW 7 Series cars. So in this case, we're looking at 3 box plots, all compared on that same scale here. This is their ages down here at the bottom. People were asked the age they were when they purchased their car. And so this is the box plot, shows us how that all panned out. So which BMW series had the largest median? So the medians here are shown with these little dotted lines. So comparing our scale there, you can see that it was the 7 Series. And now the second question goes back to some of the definitions we've talked about earlier. Which BMW series has the largest standard deviation? So if you go back and remember what we talked about, standard deviation is a measurement that talks about the range and how spread out the data are. So if you look at these 3 box plots, which one has the most spread in the data? And I think by looking at it, you can see where that min and that max is for BMW 3 Series. Looks like that would have the largest standard deviation. We don't have to actually compute it. We can just look at a picture. That's the beauty of graphically representing data sometimes. So you don't have to actually find the calculation. You can see it right in front of you. So the last part, C, asks us just to do some kind of analysis and maybe make some conjectures here. As the BMW series increases from 3 to 5 to 7, the price also increases. So this is the least expensive, then this is a little bit more, and this is the most expensive of these 3 cars that we're looking at here. So does that surprise you based on the data in the box plots? Why or why not? And explain your reasoning. So think about it for a minute. Does it make sense? Does it seem to fit with the data that as the cars get more expensive, you look and see what the ages are of the folks that are purchasing these cars? So in my opinion, I would say that this does not surprise me to realize that as we go from the 3 to the 5 to the 7, it gets more expensive, mostly because it looks like the age of the person buying these for the first time increases as we go from 3 to 5 to 7. And I tend to think that as a person gets older, maybe they're more established in their career, or they've gone through and finished their schooling, or maybe they've had their kids and now their kids are moved on to their own lives, and maybe they have more disposable income to go with. I would say, okay, that would make sense then, that older folks, or at least comparatively older, look like they're the ones that are going for that 7 Series versus somebody who's younger who would be able to only afford the BMW 3 Series. So just a way to kind of look at and interpret and think about, what is data showing me? Do I think it makes sense? How does it kind of relate in the real world? So one other thing that you might notice sometimes is all the box plots we saw in our notes here were horizontal box plots. Sometimes you will see box plots shown vertically. So if you do see that, it's still the same idea, where you'd have the minimum is going to be down at the bottom, the max is going to be up at the top, and then everything in between still falls, except now we're looking at horizontal lines instead of vertical lines. So if you see a box plot kind of turned on its side like that, that's okay. Just another way to draw that and to look at your data graphically. I hope this video was helpful for you.